have your calculators handy? Because you're going to need them today. All right. So today we are talking about proportional relationships, and we want to be able to determine if quantities represent a proportional relationship. So what we've been doing is we've been talking about ratios, and everything is about ratios, and a ratio is just a fraction. So we're looking at fractions of things and how they're related. So it turns out that if the ratios, so if the fractions of two quantities are equal, then the quantities are proportional. So if you create your little fractions, and all those little fractions are the same ratio, if they're the same decimal or the same number, then those quantities are proportional. What do you suppose it means if the ratios are not equal? Yeah, then they're non-proportional is what we say. But yeah, if the two quantities are not equal, if the ratios are not equal, then the quantities are non-proportional. All right, so it's pretty easy. We're interested in things that are proportional today, but I will caution you to read carefully in the Delta Math. They like to throw in the word not on occasion, which then, of course, which one is not proportional? So we do want to be a little bit careful. So let's look here. Eric and Lucy ran 20 minutes each on the treadmill at the gym. The table below shows the number of calories each has burned after 5-minute intervals. Complete each table and determine the type of relationship, whether or not they're proportional or non-proportional. So Eric, we have every 5 minutes, you can see they noted the number of calories that the machine said that they had burned, okay? And so we want to look at the rate. We want to look at the ratio of these two quantities. So I have a little question for you. How should we set up our fraction? What should go on top? Calories, yeah, calories per time. Typically, we would go, that makes sense, right? How many calories do we burn per minute would make sense. So that's what we're going to set up here. We want to do 70 over 5. And what is 70 divided by 5? 14. So that would be 14 calories per minute. And then I can do the same thing below, and we would divide 140 divided by 10, which is, again, 14 calories per minute. All right. Do I need to keep writing my fraction out? No. We've got the pattern, right? So is it important to write it once or twice in your notes? Yeah, to sort of tell you what we're doing here. How do we get this number, right? But once you've done it a couple times, I think I can just go to my calculator and be like, okay, 210 divided by 15. Oh, there's 14 also. And then 280 divided by 20. Oh, hey, that's also 14. Okay, so those ratios are the same for every single pair of values. And so the calories burned by Eric, is it proportional or non-proportional? Proportional. The calories burned by Eric is proportional to the time because every ratio is equal to 14 calories per minute. Every ratio is equal at 14 calories per minute. So we want to look at Lucy and compare Lucy as well. And again, the rate we would want to do would be calories per time. And so again, we're going to set up 45 divided by 5. What is 45 divided by 5? 9 calories per minute. And then I would want to do, yeah, again, 90 divided by 10 is also 9. And what about 120 divided by 15? What's that? Oh, that's 8. Oh, all right. And then 180 divided by 20, that's 9. So what's Lucy's? Non-proportional. And why is it non-proportional? Yeah, because one of them is different. Okay, so the calories burned by Lucy is non-proportional to the time because one of the ratios is different. All right. And so that's what we're doing a lot of today. The very first thing you see in Delta Math, they're going to give you a table, and they just use X's and Y's. Okay. And so all you have to do is divide. See if they all match. All right. And if they match, we know we're proportional. And if they don't match, it's not proportional. Okay. All right. Let's look here. Determine whether the quantities in each table represent a proportional relationship. If yes, give the constant rate. The constant rate is that ratio that we're investigating. So whatever that ratio happens to be, they want to know it if it is proportional. So again, we have number of buses, how many buses we have, and then the number of students on those buses. So how are we going to set up our little ratio, do you think? What would make sense? Yeah, the number of students per bus. And that makes sense when you think of riding a bus. We are interested in how many students are on that bus usually, right? How many students are on each bus. And so I want to set up my ratio here for number 1. I'm going to put students on top. So 24 divided by 1 is 24. And here we have 45 divided by 2. It's 45 divided by 2. Not 24, 22.5. Do I need to keep going or can I stop there? I can stop because I already know, is this proportional or not proportional? No. Not proportional. All right. It is not proportional. So I can just stop right there because those ratios are already different. Oh, let's look at number 2. Hours worked. I have the number of hours someone has worked, and I have the amount of money that they earned. So if you're thinking about those things, how should we set up our ratio? What makes sense? The most sense? Money on top, yeah. So I would want to have the amount of money that we earned per hours worked. Usually time goes on the bottom. And this is how we think about being paid, right? How many, if you work a certain number of hours, we want to know how much we work per hour. How much money do we earn per hour? So like if you worked at the Landing when you're a little older, you'd get like $14 an hour to start. $14 an hour is really good. My first job, I got $5.25 an hour. It was awful. No, I worked at a daycare. Yeah. I was so sick. we worked this summer. I was so ill. I had the flu twice, and that one summer was so gross. All right. So I'm going to set up my ratio at number 2, which would be money on top. So 36 divided by 4 is 9, and 72 divided by 8 is 9, and 90 divided by 10 is 9, and 135 is also 9. So is it proportional? Yes, it's proportional. What is our ratio? 9. What are the units on that? $9 per hour. Lovely. Yes. So this is why I'm writing this over here. It's going to help us figure out how we write this ratio because units are very important. $9 per hour. Very good. All right. Why don't you turn the page? And let's look at number 5 and 6. Let's look at number 5 here. We have the number of candy bars. I talked about this yesterday. It was so funny. And the cost of those. So how would we want to set up this ratio? What do you think makes sense? Yeah, cost per number of candy bars. Yeah, cost per candy bars. All right, so if we're going to set up our ratio that way, we would have money on top. So 4 over 5. What's 4 over 5? Yeah, 4 over 5 is 0.8. All right, we'd have 8 over 10. Well, that's also 0.8. Let's see, 16 over 20? 0.8. And then last one, 28 over 35? Also 0.8. All right, is it proportional? Yes. And what's our constant rate? 0.8. What are my units? 80 cents per candy bar. Yeah. Yeah, this would be 80 cents because of the decimal. So 80 cents per candy bar, which is not too bad. I try to be in the 33 cents a candy bar range myself, but you know. All right. So this one's a little bit trickier. We normally say time on the bottom, but this is actually, we're looking at how many songs are being played and the total time we're spending listening to it. And so actually for this one, our ratio would be the time per song. We're trying to figure out what is the like average time per song. And so if I were to set this up here, I'd have time on top, which is a little bit strange, but that's okay. So 12 divided by 3 is 4, and then I would compare 15 divided by 4, 3.75. So what do we know? Not proportional. All right, so that is definitely not proportional. I can stop right there. And so again, today, the first thing I think is the hardest section. Well, not really, but read carefully, because sometimes it asks which relationship is proportional and which is, or it'll say which one is not proportional. So then you got to go, oh, wait a minute. Okay, so last thing here, completing the table. If the following tables represent a proportional relationship, we want to complete the table. And so they tell us that Ben earns $8.50 per every 1 hour that he works. And this is really important. We understand what that means. He earns $8.50 every hour that he works. How do we figure out how much he earns if he worked 4 hours? 4 divided by? Multiply. Yeah, easy. So if he worked 2 hours, it'd be $17. If you worked 3 hours, it'd be another $8.50 on top of that. So we just get to do 4 times $8.50, and we get 34. How much does he make if he worked 8 hours? 68. How'd you get 68? Doubled it. Yeah, they're very good. I love that you guys do that. 10 years ago, that never would have been a response. Yeah, they never would have thought like that 10 years ago. All right. What's 10 times 850? 85. Very good. I guess I have to do this one. 850 times 14. 119. I didn't know that one. Great. All right. Number 8, a wide receiver can run 9 yards per second. 9 yards every 1 second. Every single second he runs 9 yards. How much does he run in 1 second? 9 yards. How much does he run in 3 seconds? 27. 6 seconds? 54. 90. Very good. That was easy. Mitch pays 30 cents per minute. 30 cents every 1 minute for his long distance calls. So what do I have to do to figure out his cost after 5 minutes? Yeah, 5 times point. Yeah, $1.50. 0.3 times 12. 360. Yep. 0.3 times 24. $7.20. Yeah, doubling that 360 with 36 and 36 is 72. And then 30. $9. Yes. Great. All right. So this is pretty much what we're doing today in Delta Math. Just read carefully, okay?